Hey YouTube, Tristan with Warehouse 49. Welcome to part 2 of our iSCSI with FreeNAS build that we did a few weeks ago. This is kind of a follow-up, and the reason why we named it the way we named it was because Adam Savage from Mythbusters said that failure is always an option. Remember how many times you dot your I's and cross your T's and check. There's always a possibility that you'll fail at something. And so this is me failing at this project. And even though it should have worked, we thought it would have worked, it didn't. And we're going to go over all that steps, all the processes, everything that we did, so that you can kind of see our process or methodology of going throughout this whole project. So as a recap, we bought a super micro server off eBay, had dual 8-core processors, 256 gigs of RAM, 4 12 gigabit per second, 8 terabyte SAS drives, and with dual 10 gig SFP plus slots for 10 gig networking, which we used one of the 10 gigs for our build. And more importantly, why are we doing this? Why did we want to go this route? Well, if you know our venue, we have 16 gaming computers, and each one of them has 2 terabytes worth of data space for games, as well as a 256 gig SSD. And what we wanted to do, what we did in the beginning was we stored the games on the 2 terabyte drive on each computer, because that's just how we get enough games on we get all our games on that computer without taking up all the space on the SSD. So we used in the beginning, I created a bunch of in each launcher, Steam, Blizzard, Epic, Origin, all those, I created paths saying, hey, when you install a game, go to the secondary drive, don't go to the first drive. The problem with that was some launchers didn't care and made you choose which one to go with, and didn't by default choose the secondary drive. So it would just, people hit next, just install to the C drive fills up. That's a problem. So I created a script that would map, create these things called junctions, which are kind of like shortcuts. It's a really old technology, and they look just like shortcuts to you, the user, but to the computer, they look like folders, just going somewhere else. In fact, when you go in that folder, it doesn't go to that place that you pointed to, it goes deeper into that folder. So it looks like a folder, but it's actually a shortcut somewhere. We use junctions, and what we did was when we installed the games, we created the folders first. And so like Steam, we created a Steam folder on the D drive, which is our secondary drive, and we made a folder on the C drive called Steam, and then we just told that Steam to go to the other folder. Worked out pretty good, and that's how we did things. However, what we want to do is we would like to store all the games on a single network device, and this way we can get rid of the drives in the computers, because those drives are heavy, they add up, there's 16 of them, they're fragile, and each computer uses a different amount of the 2 terabytes, and so some of it gets wasted just not doing anything, and some get more utilized than others. And so if we can create a way to have a big pool of space and everyone can have up to their allotted amount of space, but it would grow and shrink and things like that, I think it'd be a much better utilization of our resources. And so what this would result in a lighter computer and a more resilient data structure, being that if a drive fails on our server that has all the games, no computers would go down. We just replace the drive eventually and everything would be just fine. Whereas if a drive fails on a single computer, that computer's down until we figure out how we want to do it, put the data back on the C drive, what not. Now, if the server dies, yeah, if a CPU explodes or something like that, most of it's redundant, but there is issues like, what if the controller dies that's controlling the hard drives, or what if some weird thing on the motherboard explodes? Yes, all the computers would go down at that point. So you're kind of moving your risk, but it's server hardware, so you'd probably get a lot better protection from that. So what was our initial setup, our proposed setup? What we're going to do with a Supermicro server? Well, we'd install FreeNAS, which we did on the server, and create an iSCSI target for each computer. And what an iSCSI target is, if you look at our old video, it's basically just a virtual hard drive that you can give to Windows, and Windows goes, hey, that looks like an actual hard drive. You format it and everything. It's just like a regular hard drive. Everything is treated the same, but it's over the network. So that kind of fills our bill that we want to get done really nicely. So that's what we did. We did that, created one for each. My initial test was 8 computers. Which I wanted to kind of be the threshold before doing it to the other 8, but I first tested on the first 4 computers just so I didn't do all the work all over again. So I set the server up with a RAID Z1, which means one drive can fail and you'll still have all your data, which is nice because that's what we need, that redundancy just in case one drive does fail. We need to be able to, the LAN party has to keep going. We also wanted to make sure that we took advantage of ZFS, which has awesome caching capabilities, so that would cache games. So if 3 or 4 people wanted to play League of Legends, it would keep it in memory, and each other person would just get the memory, and it would not hit the hard drives, meaning things would go really, really quick. We also want to take advantage of the dual, or at first single 10 gigabit per second fiber optic cable that we had, and then eventually utilizing 2 in some sort of redundancy, and we wanted to combine the throughput of both of them as well. And this way we'd have 20 gigabit when they're both were up and going. We probably wouldn't be able to utilize all that, but at least it was there if we needed it, which was when the problem started arising. So iSCSI apparently has, like any protocol, has a little bit of overhead, meaning that, you know, if your network is capable of going at a certain speed, iSCSI takes a little bit of it for itself to do what it needs to do. Okay, that's fine. I can deal with that. However, what it resulted in was bounding traffic. And what I mean by that is that we'd have really awesome speeds at first. We'd be maxing out our gigabit link to each computer, and then it would just crash down to 0, which is a problem. Because one of our thresholds that we wanted to meet to call a success was we want to get 4 computers uploading data to the server, full gigabit, at one time without any issues. That's what we wanted, or at least as close as possible. And we could only get 2 computers to go up to transfer to the server at one time without any bounding issues. And even at that, like, eventually it did happen. And so that was a problem. We can't have a less experience for gamers if we're going to be using the system. It has to be just as good, if not better. If not, then what's the point, right? You have to make it better for a gamer to get them out of their house. Like, why go to a LAN party or a venue if their experience is going to be subpar, right? And really you're going for the social experience, but still, even with a social experience, like, you know, hanging out with your buddies, you don't want to do it at a subpar level. So that was a problem. We wanted to fix this. So I did more research, and the first thing I did was, apparently the more amount of VDEVs, which are virtual drives that you have inside your server, the faster things go. So what I did was there's a write penalty when you have RAID Z1, which is you can have one, basically RAID 5, you can have one drive fail. And so what people have recommended was doing a striped RAID Z configuration, where you have we have 4 drives. So we put these two will mirror each other, these two will mirror each other, and then they'll stripe across, meaning that they'll share the workload, which means we can have two drives fail as long as they're not in the same pair, and you'll still have your data wherever you need it, but more importantly, we get better write performance. You lose literally half your data worth of drive space initially, but since we were using thin provisioning where we don't allocate the full 2 terabytes to each computer right away, we could deal with that, and if we needed to, we can buy more drives later. Okay, let me try it. It was better. It wasn't great. We could get like 2.5, 3 computers worth of full gigabit bandwidth before we had the bounding, but it wasn't good enough. So that was not really good to what we wanted to do. And then I read that even at that, ZFS doesn't really cache iSCSI stuff really well, because that ZFS is known for their caching capabilities. So things would go into cache from iSCSI, great, but then when you deleted data, like let's say you downloaded an update to a game and it's installing the update, ZFS didn't really have a good way to get the data out of RAM for caching, out of the cache, and so that data would come stagnant until you restarted, and that was a problem because we need to have fast access to these games. And what's the point of having dead data in the cache? So iSCSI really quickly, without more drives to spread across those writes and to improve performance, it was really kind of becoming out of the question for us, unfortunately. So what we're gonna do? So I was like, well, we'll go to a share. We'll test this thing out. We'll go back to basics. We'll just create a basic share and just store our games on there. One thing I knew is that Blizzard doesn't like to be on a network drive. That I did know, but I was going to try it anyway. Maybe things change. Things do change over the years. So we got really good speeds. We were able to get all 8 computers going, uploading their data, their game database, all at one time. It slowed down significantly, but not enough for me to be like, that is a problem, because I know that not all 16 computers will be uploading data at one time, and if they are, it's going to be short bursts of data, 20 gigs, 100 megs, 40 gigs, at most 100 gigs for the biggest games if you're installing a new game. Not a problem, because you're going to have computers transferring data and then stopping. Other ones are going to be taking a little bit longer. That's not a big deal. So I was happy with that. That's pretty fast. Like I said, just about full gigabit. At 4 computers, all 4 were able to transfer at gigabit speeds at the same time. That was pretty cool. Okay. But Blizzard, how are we going to handle this? Well, I know a trick, right? And the junctions. Well, remember I was saying junctions are old technology? Well, it is. It's from back in the XP days. Windows 98 days, where you didn't really have too much networking going on. In fact, networking didn't happen until Windows 98 with Networking Edition, for those of you who remember that. So junctions are a really dumb, smart way to get things, to trick things into thinking they're somewhere else. So I went ahead and created a junction for Blizzard. Say, hey, Blizzard, that folder's actually on the network. It didn't work, because junctions don't support networking. Crap. That's not going to work. So, did more reading. What you can do is create something, a newer technology called System Link. And what that does, it does know how to traverse the network. Great. So now, but Blizzard, of course, knows System Links and goes, that's not a network drive, or that's a network drive, it's not local. Put everything local, try it again, see you later. Okay. Crap. Let me do some more research. Apparently, you can create a system link to a network drive and then create a junction to that system link. So let me try that. It didn't work. it successfully tricked Blizzard, but I had a weird DLL issue that I couldn't get around. So how was I gonna fix that? I don't know. That's a weird thing. I looked it up. Not a lot of people are doing this, and so not a lot of people are having that issue. And if they are, it's with different programs for different reasons. If reinstall and everything works fine. Tried it, didn't work. Crap. Okay. What do we do from there? Well, I tried using VDH, which is for Windows 10 and Windows 7, stuff like that, virtual hard drives that are you can built into Windows. You can, where iSCSI starts on the server, and you kind of point it to a computer, and the computer kind of takes that and goes, yes, I want that hard drive. What a VHD does, creates a virtual hard drive on your computer and stores that file somewhere else. So it originates from your computer. But VHD by itself doesn't support thin provisioning, which helps with the not needing exactly 2 terabytes for every computer, which we need because we don't have 2 terabytes worth of data. We only had 14 terabytes where we needed 32 if we wanted to give each computer 2 terabytes. Okay, well, luckily now we have something called VHDX, which will allow us to do thin provisioning, which is super cool. So I did that. I did that for the first 4 computers. And it seemed it worked. Blizzard was happy. I can move on now. I can go on to more testing. Okay, let's do this. And I didn't move Steam over at this point because I said, why bother at this point? If just for Blizzard, maybe we'll just keep the virtual hard drive just for Blizzard and leave the rest by itself on the shared drives. So I started doing testing, and everything seemed to be working pretty good. Like on one computer, I saw the fastest ever download of a game that I've seen at the center, and we're only doing like 90 megabyte, which is like 900 megabit per second, a little bit less with conversion, but still it was really fast. I was like, this is great, this is awesome. So I tried doing it on all 4 computers, on all 4 test computers. That's where issues, surprise surprise, started arising. So apparently Steam doesn't like network latency when it comes to their games. Especially installing, downloading, stuff like that. And if it detects too much latency, so I've been told, I don't know how to verify this, it will just close. Just no error, nothing, just poof, gone. As soon as I saw the network traffic on all 4 computers go super high, you would just see one Steam close, another Steam close, and then we had one, Steam just froze. Every time, just froze. After you got really high up there in the downloads, just froze. Crap. So I don't know how to fix that. Maybe I can reboot. Maybe a reboot will fix it, right? Reboot fixes everything. That's what first thing you're told in IT. So I rebooted, and now I couldn't find Blizzard. Blizzard just disappeared. Weird. I looked back, I looked at the computer, and the drive that we created, the new virtual hard drive D drive, was gone. Apparently, when you create a VHD, it doesn't auto connect on your next boot. And if you lose connection to that drive, it also doesn't just connect back, which is unlike iSCSI. iSCSI will try to make that connection, makes things work, and it comes back every time you restart. Why? I don't know. That's such a weird issue. So that's the issue that we had. And the only way to get it to work would be to create a script every time the computer boots to reconnect. And if it ever loses that connection, to re-establish that connection. That's a problem. Because, this is something that was supposed to be somewhat simple. I realize that it sounds pretty complicated, but it's pretty simple. In the concept of it, and creating these scripts that would have to run every time computer boots, and then every time the drive, if it ever gets disconnected, reconnected. We're getting complicated. We're getting very complicated. And I didn't quite know how ZFS was going to treat the data inside those virtual hard drives, and if it was going to cache it correctly, like it wasn't going to do for iSCSI. And I couldn't find any data on this other than with ESXi, which is VMware stuff, but there wasn't a whole lot of data on that either. So I didn't feel comfortable doing that, and so I kind of like decided there, like it's not what I wanted to accomplish. We're already past that, way past that, and making the system more complicated that way with not a whole lot of gain. We're starting to get the benefit versus the complexity ratio starting to even out, and I didn't want to do that. So that's why I decided, like, that's done. No more of that. I can't do that. And so I started reverting everything back. And so this was probably about a week and a half worth of testing that I had to do, because every time we had to redo something, oftentimes I had to wipe it and re-upload everything. And I spent around anywhere between 4 and 12 hours a day, more so on like the higher end of that scale, working on this project to try to get it working, especially since Dungeon Con is coming up and I wanted to really tout it out there and test it there. So what we did was we went back to secondary drives and we went back to junctions. However, good news, right? Just as failure is always an option, you learn from it. And so while the project was a fail, I feel like there was success in there, as in I was able to optimize the scripts I was using for new computers to put the folders on the secondary drive and to create the shortcuts on the C drive, in a point where I was able to keep the launchers on the fast SSD and put all the games by themselves on the D drive. The way I did this was I looked up how every game stores its game files, which everyone's different. Every single one. You know, Steam has app data for their games underneath the Steam folder. Blizzard creates a new folder on the program files for each game. Epic stores, from what I can tell, their games in the 64-bit of program files. Super weird. So everything's a little bit different. Even good old games and Origin, they're all different. So I found out where they do each one of them as best as I could and created the junctions for the games. So now all the games are going to be on the D drive and all the launchers are going to be on the SSD and be super quick. Awesome. So what are we going to do if we wanted to do this again? I kind of hit that point in the beginning, but either more drives, which is now you're getting back to the heaviness of having that many drives anyway, or all SSDs to create a super low latency connection. I don't know how I'd get around the Blizzard issue of not wanting to be on the network. I would probably have to go back to iSCSI and hope that we can get around that bounding issue that we see, but it's possible. I would love to revisit it with SSDs. It would have to be like 2 to 4 terabyte SSDs with 4 of them at least, or if not more. But I would love to do it. So we'll probably never do it without a sponsor because that's a lot of money. But we have the server, so I mean that's the first part. So if you are looking to sponsor one of our videos, maybe that would be one. Maybe if you're Samsung or any other awesome SSD drive manufacturer, reach out to us. We'd love to do that project. We'd love to show the process of doing that. So that'd be awesome. So then, you know, what are we gonna do with the server? We're not gonna let it go to waste. Don't worry. We're still gonna do testing on it because there's a lot more we can learn from it. But what I'm thinking about doing is having it as a server for all the community content creators out there that we have, because sometimes like 4K, this video alone is probably over 30 to 40 gigs worth of 4K footage. Having space is a necessity. Having a place to get out of the office and work on your videos is a necessity. So I'm thinking about having the server set up with permissions, and so creators can come in and work on their video at the warehouse and have a place to store it. We might even put in a nice big video card so that people can do transcoding on it as well and get their videos transcoded quicker so they can get them uploaded quicker. That would be pretty cool. And then in the meantime, as I'm doing that, we might also store at least a copy of the games for the computers on that server. I'm creating another script, a bunch of scripts for the warehouse where for Steam, it will check the server and check the local computer. If the server has a newer copy, it'll actually download that game and delete the local copy. But if the server has an outdated copy or doesn't have it, the script will actually upload the game to our server. And this way, if a brand new game comes out and someone downloads it quick, kind of like Call of Duty or something like that, or even Fallout New Vegas with the texture pack, 4K texture pack, we'd be able to upload it and then distribute it out to all the rest of the computers. For LAN parties, I want to make a modification for the script for people to download the base game from our servers, and this way when they update, they only have to update to get them to the latest version, not the base game. And that could save a lot of time. We kind of did we did that actually yesterday at the warehouse, where we had a guy who wanted to play the new Call of Duty game, but it was 140 gigs. And no matter how fast your internet connection is, that takes a while. But I knew that one of our computers already had it, and so I was actually able to get a copy of it and get him the base game. And so all you need to do is have a 40 gig update. Awesome. That took so much less time than 140 gigs. Plus we actually have a limit on our internet. So 1 terabyte, that's all we get a month before we get charged more. This is going to help that. And then he was able to upload that to our server. And now we have a fully updated game that we can distribute to anyone else who needs it instead of downloading the full game. It's going to be quicker, and it's not going to hit our data cap as much. Plus, the more bandwidth for gaming. So that's the other project I kind of want to work on as well. What do you guys think? Do you guys have any suggestions of what we can do with the server? Do you have any suggestions how we could have made this work with the current hardware setup that we have? Let us know. You want to see any other videos? Also leave those suggestions in the comments, because we would love to do more videos like this where we can explain, maybe how to install FreeNAS, the different RAID Z files, RAID types, just RAID in general, the difference between an HBA versus a RAID card and things like that. We have a lot of this hardware, cool hardware here that we can play with. It's just we need to know what you want us to show you. We'll still come out with cool videos, of course, but with your help, we can do the ones tailored to what you guys want to see. So let us know. If you liked it, give it a like on the video. Please subscribe to us. It helps us. Lets us know that you're watching, that you want to see more content. And leave a comment, even if it's just to say hi. We'd love to hear it. I'll try to respond to just about all the comments I can, as long as they're constructive, of course. And we'll see you next time. And hopefully you'll be at the warehouse. Take care, guys.